Okay guys, so in today's video we'll be taking a look at a revision video from mathsgenie.co.uk and it's looking at perpendicular lines, an equation of tangent, and it's looking at grade 9 maths. So this is specifically for the higher tier only, okay, and this is appropriate for papers 1, 2 and 3, okay, but at the time of recording this you'll be preparing for your paper 3 guys, okay. It's appropriate for Edexcel, AQA and OCR and IGC and CIE, WJC, CIE and all the other exam boards, okay. As ever guys, please feel free to obviously pause the video, try the questions yourselves and then press play when you're ready. This is question number 1 guys. A is the point 0, 1, B is the point 10, 6. The equation of the straight line through A and B equals y equals half x plus 1. Part A. Write down the equation of another straight line parallel to this equation. So parallel means it has the same gradient, so the same coefficient of x, but a different value of c from my equation y equals mx plus c. Okay, so it would be, let's say y is equal to a half x, okay, plus 7. Okay, let's say. Okay, I try to always avoid putting the same number here, okay, because yeah, just to make it very clear that this is actually parallel, but it's not the same as this line. So it goes through 0, 1, okay, but it's parallel, sorry, 0, 7, sorry, but it's parallel to AB. Okay, so parallel means it has the same gradient, guys. Okay, this is part B. Write down the equation of another straight line that passes through the point 0, 1. Okay, so this time it's saying equation of another straight line that passes through the point 0, 1. Well, I can have the equation y is equal to 2x plus 1, okay, provided that I have that plus 1 there, because in this case c is equal to 1 from my y equals mx plus c. Okay, so just to do like a brief recap guys, y equals mx plus c is the general form of an equation of a straight line where m is your gradient and c is your y-intercept. Okay, if it goes through the point 0, 1, okay, when x equals 0, m will be equal to 0 as well, because x times m, sorry, 0 times m is going to be 0, plus c is equal to y. Y at that point equals 1, so c is equal to 1. Okay, so it's any equation where the plus c is equal to plus 1. Part C, find the equation of the line perpendicular to AB passing through B. So a perpendicular gradient is the negative reciprocal of my current gradient. Okay, so currently it's equal to a half. The negative reciprocal of a half becomes minus 2. Okay, so it's minus 2, okay, and it's perpendicular, okay, through B. So it passes through the point 10, 6, okay. So my equation is y equals minus 2x plus c, okay, and I can substitute in the set of coordinates to work out what c is, because c equals 6 when x equals 10. So I'll have 6 is equal to negative 2 times 10, which is negative 20, plus c. Rearranging this equation, we get that c is equal to 26. Okay. So the key parts to remember guys, that a perpendicular gradient is the negative reciprocal of one another, okay, so it's a negative reciprocal, so I flip the fraction, it's the reciprocal, so I flip it and then I make it a negated sign, okay, so if it's currently negative it becomes a positive, if it's currently positive it becomes a negative, okay, so it's the flip version and I make it negative, okay, because the idea is that the product of the two gradients has to multiply to give me negative 1. Okay, so c is equal to 26 here, guys. Okay, this is question number 2, guys. Okay, a straight line passes through the point with coordinates 4, 7 and is perpendicular to the line y equals 2x plus 3. Find the equation of line L. Well, the perpendicular gradient of line L will be negative a half because it's the negative reciprocal of 2. So I flip it and then I make the sign negative. Okay. So y is equal to minus a half x. Okay. Plus c. Okay. C is equal to 7 when y is equal, y is equal to 7 when x is equal to negative 4. Negative a half times 4 is negative 2 plus c. Rearranging that, adding 2 to both sides, I get that c is equal to 9, guys. Okay, so once I know what c is, I can just delete this and replace it with the number 9. Okay. And similarly on this question, I can delete the plus c and change it into a plus 26, guys. Okay, this is question number 3. A straight line passes through the points 0, 5 and 3, 17. Find the equation of the straight line. Well, the gradient is the change in y divided by the change in x. So rise over run. So it's a difference in the y coordinates divided by the difference in the x coordinates. 17 take away 5 is 12. 3 take away 0 is 3. 12 divided by 3 is equal to 4. So it's y equals 4x plus c. And we know that it goes through the point 0, 5. So it's 4x plus 5, guys. Okay. So that's my answer for that one. Okay, this is question number 4, guys. Show that the line 3y equals 4x minus 14 is perpendicular to 4y equals negative 3x plus 48. Well, rearranging this, dividing both sides by 3, I get y is equal to 4/3 x. Okay, subtract 14 over 3. Okay. So the gradient of this one is 4/3. That means the gradient of the other one has to equal 3/4. But we're going to show that by rearranging the second one. So dividing both sides by 4, we get y is equal to minus 3/4 x. Okay, plus 48 divided by 4, which is going to be plus 12. Okay. So in this case, this and this are negative reciprocals of one another, okay? Because the products of the perpendicular gradients have to multiply to give me negative 1. And I can prove that because 4/3 times negative 3/4 gives us negative 1. Okay, so I've shown that here, guys. It's the negative reciprocal. So the perpendicular gradient of 4/3, I flip it, which becomes 3/4, and then I put a minus sign, which is minus 3/4. Question number 5. Here are the equations of 5 straight lines. Okay, part A. Write down the letter that is parallel to y equals x plus 6. The letter here is going to be R. Because the coefficient of x here is equal to 1, the coefficient of x is also 1. Okay. Part B, write down the letter of the line that is perpendicular to y equals 2x minus 1. So the gradient has to be minus a half. So it's going to be letter S. Okay, because the negative reciprocal of 2 is minus a half. Okay, 2 times minus a half gives me negative 1. Okay, so the product of the two gradients, okay, if they're perpendicular, has to give me negative 1. This is question number 6, guys. The point A has the coordinates 2, 5, and point B has the coordinates 6, 7. Part A, find the midpoint of AB. So we add the x coordinates and then we half it. So 2 add 5 is 8. 8 divided by 2 is 4. Okay, 5 add 2 is 7. Divided by 2, and I get 6. So the answer is 4, 6, guys. Okay, part B, find the gradient of the line that passes through, okay, AB. So the gradient is the change in y divided by the change in x. So 7 take away 5 is 2. 6 take away 2 is 4, so I get the answer of 2/4, or it's equal to a half. Okay, so 7 take away 5 is 2, divided by 6 take away 2, which is 4. Okay, so the gradient is equal to a half. Okay, this is part C now, guys. Find the equation of the perpendicular bisector of AB. So it's a negative reciprocal of a half. So the perpendicular gradient, so I'm going to label that as PM, for perpendicular gradient, becomes -2. And it passes through the point 4,6, because that's exactly bisecting AB in the center, okay? Because finding the midpoint, that's bang on the middle of doing a perpendicular bisector, okay? It's bisecting it, so it's passing through the midpoint of coordinates A and B, okay? By definition of the word bisector. Okay, it bisects it, so it cuts it exactly in half. So it's going to be y is equal to -2x plus c. Okay, y is equal to 4 and x is equal, sorry, y equals 6, x equals 4. So 6 is equal to -2 times 4, which is -8, plus c. Okay, adding 8 to both sides, I get c is equal to 14. So my answer is y is equal to -2x plus 14. Okay. This is question number 7, guys. Okay, a circle has centre 2, 5. The point A lies on the circumference of the circle. Find the equation of the tangent at A. Okay, so it has a centre 2, 5, and A lies on the circumference. Okay, so if we work out the gradient, okay, from the centre, so if we just draw like a little sketch here, because it might actually help us here. So 2, 5, that's at the centre, okay? Imagine that it's going to look something like this here, as like a rough sketch, let's say. That's 2, 5, okay? And then it goes to 11, 8, which is going to be 11 across and then 8 up. So let's say it's approximately here. That's going to be point A, okay? Which is going to be 11, 8, okay? We want the equation, okay, of this line here. So a tangent touches the point, touches a circle at one point. In this case, it's 11, 8. So we're going to work out the gradient of 2, 5 and 11, 8, and then work out the negative reciprocal, okay, of that. So 8 take away 5 is 3. Okay, 11 take away 2 is 9. So it's 3/9 or 1/3. Okay, so that's the gradient of this line here. Okay, this one showing here in blue. Okay, that's the gradient of this line. Okay, so the negative reciprocal of 1/3 is -3. So it passes through the point 11, 8. So if I just sub this into my equation, y equals mx plus c, I've got y is equal to -3x plus the c. Okay, so subbing in x is 11 and y is equal to 8, I get 8 is equal to -3 times 11, which is going to be -33, plus c. Adding 33 to both sides, I get that c is equal to 41. Okay, so c is equal to 41, guys. So it's going to be y equals minus 3x plus 41. Okay, I do appreciate that I am going through this fairly swiftly, okay, but I'm trying to treat this as like a revision video. So the key parts from today, yeah, I will say at the end actually again, guys, is the perpendicular gradient, okay, of a line is the negative reciprocal of your current gradient, okay? The products of the two gradients have to multiply to give me minus 1. This is question number 8, guys. A circle has the equation x squared plus y squared is equal to 5. Write down the center of the circle. So the center is going to be 0, 0. Okay. Part B, write down the exact length of the radius of the circle. So it's going to be the square root of 5, yeah? Because it's x squared plus y squared is equal to r squared. R squared is equal to 5. Therefore, the radius is equal to the square root of 5. Okay, next part. P is the point 1, 2 on the circle x squared plus y squared equals 5. Work out the equation of the tangent at point P. Okay, again, so working out the gradient of the center to point P. So working out the gradient of OP, where O is the center and P is the point on it. Okay, so it's going to be 2 take away 0 divided by 1 take away 0. So the gradient here is going to be equal to 2. Okay, so 2 divided by 1. So 2 take away 0 divided by 1 take away 0. Okay, so I get the answer of 2. Okay, the perpendicular gradient, which is the equation of my tangent, is going to be negative a half. Okay, and it passes through the point 1, 2. Okay, so we're going to have 2 is equal to minus a half times 1 plus c. When I sub this into what my equation y equals mx plus c, okay, rearranging this, I get that c is equal to 2.5 or 2.5. Okay, so c is equal to 2.5 or 2.5. Okay, so my equation of the tangent, I'll put it here, guys, because I haven't got much space here. I'm have to delete it. So it's y is equal to minus a half x plus 2.5 or 2.5, or I'm going to put it as 5 halves, okay? But either way is fine, okay? 5 halves, 2.5 or 2.5, okay? That is also fine and appropriate, okay? So I hope it makes sense, guys, okay? So I work out the gradient of O to P, where O is my center of origin, okay? Which is going to be 0, 0. And then I work out gradient of OP, 7 take away 1 divided by, sorry, it should be a 2 there, not a 7. Sorry. Looks like a 7 there. Okay. And then I work out the difference in the x coordinate. Okay. And then I just work out my perpendicular gradient, which is going to be minus a half. And then I sub in the coordinates 1, 2 in the equation y is equal to minus a half x plus c to work out what the value of c is. Okay, and c is equal to 5 halves. Okay, this is question number 19. The diagram shows a circle of radius 5, center the origin. Find the equation of the tangent at the point 3, 4. Okay, so it's this equation here. Okay, so working out the gradient of this is going to be 4 take away 0 divided by 3 take away 0. So the gradient of this line is going to be 4/3. The gradient of the tangent is a negative reciprocal, so it's going to be minus 3/4, and it passes through the point 3, 4. Okay, so my equation of my tangent so far is y is equal to minus 3/4 x, or 3x over 4, okay, plus c. Okay, I'm now going to substitute in the set of coordinates 3, 4 to work out my value for c. So 4 is equal to minus 3/4 times 3, which is going to be minus 9/4. Okay, remember that if you multiply a fraction by a whole number, you times the numerator by the whole number, but keep the denominator the same. Okay, plus C. Rearranging this, okay, so that's going to be 2 1/4. So 4 plus 2 1/4 is 6 1/4. Okay, so C is equal to 25/4. Okay, so that means my final answer is y is equal to minus 3/4 x, okay, plus 25/4. Okay, so hopefully it makes sense, guys. Okay, so I'm classing this as like a revision video, so I apologize if I went too quickly. Okay, but hopefully you found it useful. If you did, please press like, please subscribe to the channel if you're new, and lastly, please click that bell icon so you don't miss out on further videos, okay, on this channel. Okay, but essentially it is like a revision and a recap video looking at perpendicular lines and parallel lines and equations of tangents. But the key part to remember from today, guys, is the perpendicular gradient is the negative reciprocal of your current gradient. Okay, so the gradients multiplied together has to give me -1. Okay, and it's always in the form y equals mx plus c, where m is your gradient and c is your y-intercept. So c is where it crosses on the y-axis or y-axes. Okay, and if they're parallel, it means it has the same gradient. Okay, so that's it from me today, guys. Thanks for watching. Take care. Best of luck in your paper 3 exam, and I'll see you for the next one. Okay, bye for now.